Hi everyone, welcome back to my channel. Have you ever wondered how your phone lets you recognize your face or how virtual assistants like Siri or Alexa understand what you are seeing? And what if I told you that a digital brain behind all of this? So a system that learns just like we do. It's like when you start learning something new, it's like sometimes you will start with learning some, let's see, something with wrong information and it will be updated over time. This is how the neural network working. So what exactly is a neural network? Imagine a computational model inspired by a human brain, just like our brains process information through the millions of interconnected neurons. And neural network mimic this structure to learn from data. But how do they do it? So neural network is just internal parameters, are just internal parameters. As you can see, these are the internal parameters here. I will just show it in the next section. So it's just adjusting these parameters so the output will be as, let's see, as a target, as we need. So, as I said, it's called these parameters called weight in the neural network. And to make a prediction or decision, think of it as a digital brain that gets smarter with experience, consistently refining its understanding based on the data it processes. So even if you see how the kids is learning, it's just learning by, let's say, comparing some stuff and updating the information and until he is able to do something. So and as you can see, it's this information, this neural network, it's coming, or let's see, mimic the human brain. But but where the data, this data, the idea came from? It starts with biological. So it's like our brain here. You can see here, and they try to mimic this, uh, the processing in our brain, and mimic it as a neural network. And you have an input, so you have some processing unit. Let's say this one here, and you have the output. So what are the main component of of the neural network? We have one is the neuron, which is, for instance, the this here called neuron, and it's the basic building block of neural network. And neuron compute the weight sum of its input, adding to the bias. This is the bias, and pass the output to the next uh, neuron to the next neuron, and this output from this unit here, it will be considered as an input to the next, let's say, neuron. And the weight is a connection, is strength, the connection between the neuron and the bias. The bias is a constant value that will be added to the weight sum. Bias shift the activation function, allowing the neural network to fit the data better. And it's like giving the neuron a little nudge in the right direction. And the activation function introduce non-linearity into the network. So maybe one question in the interview: what is the goal behind the activation function? It's like introducing non-linearity using some activation functions. And the layer, of course, we know the layer. For instance, this is the input layer. Here, for instance, if you have a large, oh, here you can see it here. This is the input layer, and this is the output layer, and this is the hidden layer, and this is the output layers. And this input layer, it's not updating anymore. So, for instance, you have a data. I will just explain it in a moment. But the output data, it will be constant in all of these iterations. We will see it in a minute. And let's say, for instance, see this is as a black box. Input layer receive raw data, for instance, text, pixels, numeric values, and etc. And here, hidden layers is learn complex features. And if you see in a deep learning, some systems having many layers, hundreds of layers, thousands of layers, and number of millions of parameters. If you see it in a LLM, and the output layers is producing the product, the prediction. It might be a probability and also a classification if you have a classification, but it mainly produce probabilities. And if the probability is greater than a specific threshold, it should be classified, for instance, to any class. So what are the type of neural networks? Is feed neural network, recurrent neural network, and CNN network. And feed network, it's like this one, for instance, here is called feed forward network. It's like each node, it has to be connected, or let's say called, for instance, fully connected layers. For instance, this one here is fully connected layers. That means each node will be connected to the next node. For instance, you see here, this one here, it's connected to this and this. This is generated by, let's see, the ChatGPT, but it's not like a good example. And let me just show it here. Neural network. For instance, this node here is connected to all of these nodes. That's called fully connected layers. And recurrent neural network is used for sequences like languages, and recurrent neural network and transformer is used for languages. And also transformer latest in the latest time it will use for the also for computer vision, for object detection, object segmentation, and etc. And the CNN is used for video and image analysis, because it's if you imagine image with hundreds of pixels. So, and if we try to use the whole pixel, for instance, let's say assume this is the layer, the input layer. So if we have one image with thousand, let's say, pixel, we will add here 1,000 pixel here. So this too much, right? So that's why we need to use a convolutional network. This will be explained in the next videos in a super easy way, and I'm quite sure that you will understand everything, but not in this lesson. This is only a basic. And assume this is a simple network here. So we have x1 and x2, and every input has, let's say, a parameter, and the parameter will be added to the bias and to output the y, let's say the target. And this is the easy this is the equation here. You have y, weight 1 multiplied by x plus weight 2 multiplied by x2 plus bias. This is to output y, but we need also, after this calculation, we need activation function, as we have seen in this let's say activation function. This is also needed. As you can see, this is activation function. And this activation function, it will try to output, make the output into a specific, let's say, range. And after this, after y calculated, for instance, let's assume this, I have x1, x2, right? And I have x1, x2, x1, x2. This is, for instance, my dataset. This is, let's see, my dataset. And I'm trying to get the y. So in the beginning, in the first time, I will add replace x with, for instance, here 1 and 1, and calculate this calculate y with this, with the help of this formula. Then the second input will be 2 0, then and etc. But in neural network, it somehow take all of this in a vectorized method and to make it in one time, let's see. But this is the case. It will take this input and this input and this input to calculate the y. Now the activation function is used to, as we said, it's adding non-linearity to the output, to the output of the neuron. And we have many, let's see, activation functions, but these are the most, let's see, important. Of course, we will have in the next videos, we will see many of these ReLU and what is the best use and when to use or when not to use it. For instance, like ReLU, it's like a key that only open for a positive number. For instance, if ReLU it used, if you have a value, for instance, negative, it will be replaced to zero. It's like taking the maximum value between zero or the output. And as you can see here, the output range is zero and infinity. And the sigmoid function is used between zero and one. This called this used for classification. And you can see here, the ReLU function is used for hidden layers. It's not, don't try to use it in the output layers, because the output it will be from zero to infinity, and you will not be able to, let's say, classify or detecting the values. And Tanh function, it's like a sigmoid function, and the output range is -1 and to 1. And this is best used cases. To use this one is used for inside in the for the hidden layers, and not for the output layers. And sigmoid function is not used for sigmoid for hidden layers. If you know why, this will be of course explained in the next videos. But for now, sometimes the sigmoid function, after the derivative of sigmoid function, the values will be close to zero. And if we use it inside in the hidden layers, the our network will not, let's say, learning best, because sometimes it will be freezed, because there's no movement in the, because the sigmoid function, the derivative of sigmoid function, it will be zero, it will be close to zero. And tanh is just used for hidden layers, of course, and it could be also used for the output, but it's rarely used in the output layers. And let's see, this is activation function, right? And after calculating the activation function, we need to calculate the loss, measuring the mistake. So you see here, we calculate with example. Okay, here we calculate the example. Let's see the output of y, and now we need to see, is it right? This is expected value, or it might be okay, or it might be far away from the actual value. So we need to measure the mistake and update, measure, for instance, measuring the mistake. And there are several methods indeed. One used, for instance, for regression, and one used for the classification. This mean square error is used for regression, and this cross entropy is used for classification. And now, after calculating the mistake, the measuring the mistake, now we need to update, let's see, fixing this mistake. And fixing this mistake will be try to update the weights. So you can see in this one here, for instance, x1 y1, and we need also to update only this. Let's see the weights and the bias in all the networks. So for instance, here we have only two nodes or two inputs, but mainly only the weights and bias. These inputs here will stay the same as, I mean, it's constant. It, it won't be updated, let's say. Because if, for instance, the x1 and the xy2, this is the values of x1 and x2. This won't be changed during the training or during the testing or during anything. So the updating will be updating only the weights and bias during the training. So there are several, of course, several optimizer. Let's see, stochastic gradient descent and adaptive gradient descent. So this gradient moment descent, this is, let's see, most used in all, let's say, algorithms. This is because it's super fast and accurate. And I have also tried for instance, for a small example, let's see with the same number of the creating a similar simple neural network, and as you can see, so in the beginning, I have to import the torch and see how I install it, because I'm using the beauty. What you can do is what you have to do is like this. So this is added now. Let me just to see this. You can see this is the project TAML file. So this have been added. Torch audio, I mean studio and vision, and this I have used this one here, CUDA. But in case you don't have a CUDA, it will try to download the the CPU version. So because I have in this PC, I have no CUDA, that's why I have only the to install the CPU version. And you can see after importing the torch, I import the neural network, and after and also the functionality. So, and here this is a simple class, let's say simple NN. I will initialize it will be inherited indeed from this neural network module, and initializing the parent class because it is inherited, and I have defined two layers. Let's see the two inputs from layer one, and the layer two, it will I mean the input is two, but the output is also one, only one output. And the forward process, it will try to use the sorry it will try to apply ReLU function for this output here, for this input. And what is the input here? It's a simple linear function. And this linear function, it will try to update this one here. This is the linear function. Each layer will do this one here. And because we have two inputs, it will do both. And finally, we will use a sigmoid function and returning the output of this y. Now, after calculating this, we need to update this is only forward feed. Now we need to update the weight, right? And here we initialize the class, and the loss function we use mean square error, and the optimizer we will use Adam with learning rate 0.01. And here, let's see, I need to run this for 1000 time, and 1000 time it will try to predict the model and calculating the loss as we have to explain it in the document. And here it's optimizer is clearing the gradient of the previous gradient, and now loss back propagating, calculate the loss of the gradient and optimize the weights. And this will done for every, let's say, for 100 times, 1000 times. And once everything is okay, this, and let me just run this. It will take, I don't know, because I have no GPU. Yeah, by the way, for instance, for regarding the TOML file, project TOML file, you can add the stuff here, and it will be added after when you add Beauty install. It will try to read this. I have follow. And you can see, for instance, in the ebook, the loss was 0.2, and it's reduced. Let's see somehow a bit, and after 900, because here I use after 100 should give output. After 900 ebook, the error was somehow let's see if you compare these two, or maybe four, you can see the loss function is fixed. And in this case, you can add the earliest stop, or maybe number of iterations, reduce the number of iterations, or maybe taking the best out, the best model with less error. And this we will see it in the coming, let's see, videos. And by the way, for instance, sometimes you will have this ebook. I mean, the loss function will be this 1.668, and for the next ebooks, you will have 0.017 or 0.019. So it's not like a fix that you will have always decreasing. It might be jumping based on your data, based on your weighting, initialization, based on many factors. This will be covered in the next videos. That's it for today. And if you like this video, please subscribe into my channel, like the video, and of course, if you have any question, please write it down in the comment below. I will answer it. Thanks for watching, and see you next time.